Review for Geometry, Topic 5 and 6 exam. In this video, I'm going to be going over Section 1 of the exam. Let's start with a quick review on the main things that are on this exam. First of all, similarity. Remember that similar shapes have corresponding sides that are proportional, corresponding angles are congruent, and if two shapes are similar, that means that you could map one onto the other by doing a reflection, translation, rotation, or dilation. There are three triangle similarity theorems. First of all, angle-angle triangle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. The second one is the side-side-side triangle similarity theorem. If the three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. And the third one is side-angle-side triangle similarity theorem. If two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the triangles are similar. There's also the triangle proportionality theorem, which states that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. All right, so if this line right here is parallel to this line right here, then it's going to divide the sides of the triangle proportionally, and this proportion is going to exist. Now, there was also a chapter on subdividing a segment in a given ratio. Hopefully seeing these examples will refresh your memory a little bit. When we get to those questions, I'll go over it. If you feel you need to review that, you could find more information on that on chapter 12.2. There's also going to be a lot of trigonometry on this exam. Here we have the trigonometric ratios that you should know. And remember that in a right triangle, the sine and cosine of the two non-right angles are complementary. So the sine and cosine of these two angles are complementary. So let's start reviewing section 1 of the exam, which has 15 questions. Here's our first question. Mr. Yu showed his geometry students the figure below and told them that segment DE is parallel to segment BC. He asked them to use this information to prove that segment DE divides segment AB and AC proportionally. Andrea used the slope formula to prove that segment DE and BC have equal slopes. That's important because if segment DE and BC have equal slopes, that means they're parallel. This segment is parallel to this segment right here. All right. This is the triangle proportionality theorem that I just showed you a few slides ago. Okay, Dariana used the distance formula to show that AD over DB equals AE over EC, and Carmen used the midpoint formula to show that AD is equal to DB and AE is equal to EC. Which student or students used the formula that will help them prove the relationship? Okay, and the correct answer is all three of the students used the formula that will help them prove the relationship that segment DE divides AB and AC proportionally. All right, all three of those ways could help to show that relationship. Okay, number 2. Which statement is the best explanation of the relationship between these two triangles? All right, the best explanation. So if we look at our answers, I want to point out something. All right, 2 of the answers say that the given triangles are similar, and the other two answers say that the given triangles are not similar. All right, let me underline that better. Are similar, and these two say not similar. All right, so first thing we should look at is, are these two triangles similar? Yes or no? All right, so let's look at the vertical and the horizontal sides because those are easy to examine. If I look at this vertical side, I see that it's 6 units long. And if I look at this horizontal side, I see that it's 8 units long. Now if I look at this horizontal side, I see that it's 4 units long. And if I look at this vertical side, I could see that it's 4 units long. Okay, now if these two triangles were similar, since this is 8 and this is 4, that would mean I'm dividing this side by 2 to get this side. So if they were similar, that would mean I would have to also divide this side by 2 to get this side. And we can see that 6 divided by 2 is 3, but this does not say 3, it says 4. So that means that these two triangles are not similar. So that eliminates these two answers. Los dos triángulos no son similares, así que ya puedo eliminar estas dos respuestas que dicen que sí son similares. Okay, now why are they not similar? Keep in mind that the question says which is the best explanation. Okay, personally, I don't really like this question too much. Let me show you why. Alright, so it's between C and D. The answers are exactly the same except for what they say at the end. Letter C says that the given triangles are not similar because they cannot be mapped onto each other by a series of reflections, translations, and rotations. Letter D says the exact same thing, except back here it says reflections, translations, and dilations. Okay? So since one triangle is bigger and the other one is smaller, that would mean that in order for them to be similar, you have to be able to do a dilation at some point to change the big triangle into the smaller triangle. So that's why the best explanation is the answer that has the word dilation in it. Alright? So they're not similar, but out of these two answers, the best answer is the one that has dilations in it, because you need to do a dilation to change it from the big triangle to the smaller triangle, and there is no dilation that will be able to change it from this one to the smaller one. Alright, so that's why D would be the correct answer. Okay, question 3. Look at the triangle shown, or look at the triangles shown. Which statement is true? Alright, so first of all, I didn't mean for my answer to be there, but alright, first of all, they all have the same thing at the beginning. It says since triangle ADC, if we look at it, ADC is this one, the big triangle, ADC. So since triangle ADC is similar to triangle AEB, which is the smaller one, right? So the bigger one is similar to the smaller one. All right, now we got to see, because they all have the same part at the beginning of the answer. So we got to look at the back part and see which is the correct answer. Okay, now if we continue to look at all the answers and compare them, the top two say side angle side, similarity postulate, and the bottom two say angle angle, similarity postulate. All right, so let's look at that now. Okay, side angle side. In order for it to be side angle side, I would need to know a side, the included angle. So like, let's look at the top triangle. We have this side is 4, this side is 3, and the angle in between them is 90 degrees. All right, so that's side angle side. Let's compare it to the big triangle. In the big triangle, this side is 12 because 4 plus 8 is 12. This angle is 90 degrees, but I don't know what this side is. I don't have that information. So I can't assume that side angle, like we can't use side angle side here because I don't know what this side is. All right, if I try to do it with, just to make sure everybody's with me, if I try to do it with this side, let me show you something. They both, the small triangle and the big triangle, they both have angle A in common. So if I try to do it like this side, this angle, and this side, again, I don't know what this side is. Just like in the big triangle, I could do this side is 12. They both have this angle in common, but I don't know what this side is. So basically what I'm trying to tell you is I cannot use side angle side. I cannot use side angle side. No puedo usar side angle side. So the correct answer is one of the bottom two. Well, we already know the answer, but stay with me here. Because, all right, so it's between the bottom two. All right, because we do have angle. We could confirm angle similarity because on the top we have triangle AEB, all right, which has angle A, and then the big triangle is triangle ADC, and that also has angle A, and they both have this 90-degree angle. All right, so that's why since they both have these corresponding angles that are congruent, all right, that means that the angle similarity postulate can be used here. Okay, now it's just a matter of checking which proportion is correct, okay? Which proportion is correct. So out of the two proportions that are correct, out of the two proportions that are there, only this one is correct. All right, so let's look at it. 12, that's this side. This side is 12 because 4 plus 8 is 12. 12 is to this side right here, x plus y, as 4 is to this side right here, x, in the smaller triangle. All right? So they're comparing, just to make sure you're with me, they're comparing this leg of the big triangle to its hypotenuse equals this leg of the little triangle to its hypotenuse. All right, so this proportion is correct. That's why the answer is D. Make sure you understand that because I try my best on as many of the questions possible to disguise them, to change them up a little bit. So it's not going to be exactly the same on the exam. So make sure you understand the question and the answer. All right, number 4. Question number 4. Mr. U dilates the triangle shown below by a scale factor of 5 with the origin as the center to obtain triangle A prime, B prime, C prime. 2 of his students made the following statements about the triangle. Camille says that triangle ABC and triangle A prime, B prime, C prime are similar right triangles. Therefore, cosine A equals cosine A prime. Geraldo says that triangle ABC and triangle A prime, B prime, C prime are similar right triangles. Therefore, sine B equals sine B prime. Which student is correct? Okay, so first of all, just to make sure that you understand the question, all right, the question is saying that there was triangle ABC, which I dilated by a scale factor of 5 to create triangle A prime, B prime, C prime. All right, so Camille is saying that the cosine of angle A in the original triangle will equal the cosine of angle A prime in the new triangle. And Geraldo is saying that the sine of angle B in the original triangle will equal the sine of angle B prime in the new triangle. Okay, and the answer is that they are both correct. They're both correct because when you do a dilation, the sides are going to be proportional and the sine and the cosine is going to be the same. All right, when you have similar triangles, their cosine and their sine are going to be the same. And their tangent, all their trigonometric ratios are going to be the same because the two triangles are similar. Okay, cuando se hace una dilatación, las figuras son similar, los lados son proporcional y el cosine, sine y el tangent, todos los radios de trigonometría van a ser igual cuando tienen dos figuras similar o dos triángulos similar. All right, whenever you have two similar triangles, their trigonometric ratios are going to be the same. All right, number 5. Which trigonometric ratios are equivalent to 3 over 5? Select all that apply. All right, so first of all, if you look at the 3 sides that we have here, the only 2 sides that are going to give you 3 over 5 is if you divide 18 by 30. That's the only combination that will give you 3 over 5. All right, because 18 over 30, if I divide the top and the bottom by 6, I'll get 3 over 5. All right, so now we just got to look at which of these ratios will give you this side divided by this side. All right, so the first answer says cosine of A. All right, from the point of view of angle A, cosine is adjacent over hypotenuse. So cosine of A would be 24 over 30. That doesn't work. How about the sine of angle A? The sine of angle A would be the opposite side over the hypotenuse side. That one works. How about the cosine of angle B? If we look at it from the point of view of angle B, all right, cosine would be the adjacent side, which is 18, over the hypotenuse, which is 30. That one works. How about the sine of angle B? The sine of angle B would be the opposite side, which is 24, over the hypotenuse, which is 30. That does not work. All right. By the way, let me just write them here real quick so you can see what I'm saying. Cosine of A would be, well, let me write it like this. Cosine of A would be 24 over 30. So that's why this one's wrong. Sine of A would be 18 over 30. And that's why this one's right. Cosine of B would be 18 over 30. And that's right as well. Sine of B would be 24 over 30, which is wrong. How about tangent of A? Tangent is opposite over adjacent. Tangent of A would be 18 over 24. So that doesn't work. That's wrong. How about tangent of B? The tangent of angle B would be the opposite side over the adjacent. 24 over 18. That doesn't work. All right? So for this one, the correct answers are B and C only. Again, on the test, it's going to be different. I mean, this is similar to what's on the test, but not exactly the same. You need to look at the questions carefully. And if you if you don't study this at all and you just try to figure it out on a test, you're going to make a lot of mistakes, trust me. Okay, number 6, the figure below shows a rectangle with a diagonal drawn. Write an equation that shows the trigonometric relationship between complementary angles. Okay, so look, first of all, we have a rectangle. Now, the definition of a rectangle is that it has all 4 angles are 90 degrees. So why am I telling you that? Because that tells me that this is a right triangle and this is also a right triangle. Okay, now remember the relationship that exists between these two angles. All right, so here are possible answers. All of these are correct. All these relationships that I wrote here are correct. They're very simple. The cosine of this angle equals the sine of this angle. And the sine of this angle equals the cosine of this angle. And then I'm saying the same thing with C and D. Make sure you know those relationships because this is an easy question that's on the test. Again, it's slightly different, but it's the same basic concept. So make sure you understand that relationship because this is a very easy question that's on the test. Okay, todas estas preguntas están en el examen. Esto es bien fácil. Tienen que saber esta relación que existe entre estos ángulos. All right, question number 7. What information about this figure would be used as a step in a proof of the Pythagorean theorem? Okay, listen. I like to explain the questions always so that you guys understand them. But this particular question, I looked throughout the book and there's no proof of the Pythagorean theorem in the book that shows what they want us to show in this question. And it would take too much time, in my opinion, to go through this when I honestly don't feel it's worth the time for this particular question. All right, so on this particular question, the correct answer is the one that shows that all 3 triangles are similar. That's the step that you need in order to prove the Pythagorean theorem. Again, I don't want to spend too much time on this question because I don't think it's worth the time to go over this. All right, but remember, there's 3 triangles here. The 2 small ones and the big one that encompasses the 2 small ones. All right, so the correct answer is the one where you're showing that all 3 of those triangles are similar. Moving on. All right, whenever you see this that I put like 8A, 8B, 8C, that means that I'm putting like 2 or 3 examples on the same question to make sure that you understood it, okay? So that's what I'm doing here. All right, if sine of 3x equals cosine of x plus 50, what is the value of x? I messed up a little bit here, but I should have put the degree sign here and out here. But whatever, that's just a small thing. All right, look, so what I'm talking about there is this. Remember that, first of all, it's telling you that they're both equal. All right, okay, so remember that when you have a right triangle, the sine of, let's say this is A, and this is B, and this is C. All right, the sine of A equals, the sine of A plus, the sine of A and the cosine of B are complementary. Sorry, I got mixed up there for a second. All right, these 2 angles, their sine and cosine are complementary. So the way you're going to solve this is by putting that 3x plus x plus 50 has to equal 90 degrees. All right, so when I combine like terms, I'm going to have 4x plus 50 equals 90. Now just solve for x. All right, so in this example, x is going to equal 10. But the key is realizing that these two got to be complementary. So this plus this has to equal 90 degrees. That's how you set up your equation. And by the way, just to explain it further, remember that we were looking at some examples earlier, and just to make up a number, right? If this is 30 degrees, this would have to be 60 degrees. So if the sine of 30 degrees, if the sine of whatever equals this cosine, that means that they got to be complementary. All right, so when you add them up, they got to equal 90 degrees. All right, so there's my explanation. And I got some more similar examples here that you could practice and see if you get the same answer. Remember, all you got to do is set up that these two are complementary. So x plus 25 plus 4x equals 90. That's how you set up the equation. And then just solve for x. In this one, 6x plus 48 equals 90. And then you solve for x. Ok, así que en todos estos ejemplos tienen que poner que lo que está dentro de los paréntesis, la suma te tiene que dar 90. Porque tiene que ser complementario. Alright, question number 9. If the sine of x equals the cosine of y, which of these are possible values of x and y? So again, remember that if they're equal, that means they gotta be complementary. Alright, the degrees gotta be complementary. So all you gotta do is look through the answer and find which are the only values that are complementary, that add up to 90. This is the only answer that adds up to 90. Okay? Esta es la única respuesta que te da ángulos que son complementarios, que la suma te da 90. So the correct answer would be D on that. All right, number 10. This is something very simple, the next question, but it was not really in the book, at least not the way that the test is asking it. All right, so let's look at this real quick. So this was not in the book, but it is on the test. Don't blame me, I don't make the test. All right, I'm just preparing you for it. So what happens if we dilate an entire line? All right, so look, pretend we have a line, right? Remember that a line goes into infinity in both directions, right? So if I dilate the line and I make it bigger or smaller, I mean, a line is still going to go into infinity in both directions. All right, so the point of the questions that are coming up are this. If the center of dilation, when you dilate a line, is on the line, then the line is going to stay exactly the same. All right, so what happens if I read what it says here? What happens if we dilate an entire line? If that line passes through the point which is the center of the dilation, nothing will change. All right, so if the center of dilation is on the line and you dilate a line, the line stays the same. All right, again, I don't make up these questions, but it's on the test. Okay, si hacemos una dilatación de una línea y el centro de dilatación está encima de la línea, nada cambia, la línea se queda igual, porque una línea sigue hasta el infinito en las dos direcciones. Así que si el centro de dilatación es un punto que está encima de la línea y se hace una dilatación, la línea no cambia, se queda igual. Alright, so with that in mind, I didn't mean to put the answers here, but whatever, let's look at it. Thomas claims that there are centers of dilation through which a dilation of line M by a factor of 3.5 leaves line M unchanged. Before I continue, hey, this is where like it comes into play. Do you understand what you're reading? Because if you understand what you're reading, this whole thing about a factor of 3.5, they could put a factor of 1 million or 99.22 or whatever. It doesn't make a difference what the factor is. So you don't need to be, if you know how to read stuff, you don't need to get intimidated because the question is very simple. Determine whether each point below represents a center of dilation that supports Thomas's claim. Select yes or no for each point. There's a question like this on the test, and listen, all you gotta do is check which point is on the line. If a point is on the line, then that means that it supports Thomas's claim. Like point A. Look at this picture. Is point A on the line? Yes, it is. then that is one of the correct answers. You put yes for that. Is point B on the line? No. Is point C on the line? No. Point D? No. Point E? Yes. That's it. If the point is on the line, it's one of the answers. If it's not on the line, it's not one of the answers. Period. That's it. Okay, así que si cuando miramos aquí, si el punto está en la línea, entonces sí puede ser un centro de dilatación. Así que ponemos que sí, eso soporta lo que dice Thomas, que si se hace una dilatación y el centro de dilatación está encima de la línea no cambia. Y si el punto no está encima de la línea, se pone no. Eso no soporta lo que dice Thomas. All right, moving on. Number 11. In the figure below, triangle DBE is the result of a dilation of triangle ABC, with point B as the center of dilation. Which statement best uses this information to explain why the AA angle criterion can be used to prove that triangle ABC is similar to triangle DBE? Okay, this question is pretty tricky, all right? Let me show you the correct answer, and let's talk about why this is the correct answer and why this is the best answer, okay? So the correct answer is B. All right, so let's look at that one first. It says a dilation takes a line not passing through the center of dilation to a parallel line. So what it's talking about is this. This is the center of dilation, and it's taking, when you dilate the small triangle, it's taking this line and creating this line, which is parallel to segment DE. So both of these lines are going to be parallel. That's what it's talking about right there. All right, so DE is parallel to AC. Okay, now when those two lines are parallel in a triangle, that establishes, when both of those lines are parallel in a triangle, you got to remember that when two lines are parallel and they got a transversal going through them, this angle will be congruent to this corresponding angle, and this angle over here will be congruent to this corresponding angle over here, which is what it's saying right here. Now, why is this question tricky? Because if you look at the other answers, I mean, there's other answers that look like they might be correct, but let's look at why they're wrong. All right. And by the way, if it's tricky, it's going to be tricky on the test also. So look at C and D. Keep in mind that this says which statement best uses this information to explain why the angle criterion. So in letter B, we're showing that you got two angles in one triangle that are congruent to two angles in another triangle. Okay. However, in letter C and D, it says by the reflexive property, angle B is congruent to angle B. Dilation results in line segments that are proportional in the scale factor of dilation. Okay, so first of all, in letter C, this proportion is wrong, but letter D, BD over BA equals BE over BC. Okay, in letter D, this proportion is correct. Okay, but this is a better answer, because in this answer, when you establish that these two lines are parallel, you're able to say that you have these two angles that are congruent to these two angles. Whereas in this one, we're only showing that this angle equals this angle. And again, the question says by the angle criterion, which is the best, which statement best uses this information to explain why the angle criterion can be used. I don't like this question because it's very, very tricky and detailed. All right, so you should definitely study that before the exam. All right, because letter D is not really wrong. Letter D is correct, but letter B is the best answer for in terms of using the angle criterion. All right, so that one's one that you should read slowly later before the exam. All right, let's move on. All right, number 12. The line representing this equation, x plus y equals 7, is dilated by a scale factor of 4.7 with a center of dilation 7, 0. Which statement is true? All right, so this is another question that has to do with dilating a line. That if the center of dilation is on the line remains the same. Okay, so The line representing the equation is dilated by a scale factor. Okay, so first of all, notice something. If I take this point, this is the center of dilation, 7, 0. If I take these coordinates and plug them into this equation, does it make this equation true or false? All right, if I plug them into this equation, it'll be 7 plus 0 equals 7. That's true. That's true. That means that this point is on the line. This point is on the line. So therefore, the correct answer is C. The dilated line lies on the original because this point, when you substitute it into that equation, it lies on the line. So this goes back to what I was saying, that if you dilate a line and the center of dilation is on the line remains the same. All right. So in this situation in number 12, the dilated line is going to be on top of the original line because the center of dilation is on the line. All right, again, I'm imitating what's on the test, guys. Do I think this is a good question to put on the exam? No, I don't. But what can I do? I don't make these exams, like I said. All right. Así que como el centro de dilatación está encima de esta línea, porque si sustituyo estos coordinados para x y y, hacen esta ecuación verdadero. Así que eso quiere decir que este punto está encima de esta línea. Así que si hago una dilatación de la línea y ese centro de dilatación está encima de esta línea, la respuesta es que la línea que hicimos esa dilatación a esa línea está encima de la línea original. Not the best translation, but it'll have to do. All right, number 13. In the figure below, triangle ABC is similar to triangle DEF. Which equation is correct? All right, so here's the deal with this one. They're using, let me explain what they're doing here. They're using the angles from this triangle and comparing it to the sides of this triangle. So there's only one equation that's correct. Están usando los ángulos de este triángulo, pero los lados de este triángulo. So the first one says the tangent of A, remember tangent is opposite over adjacent, equals DF over EF. That's wrong because it should be, this is the opposite. The tangent of A corresponds to the tangent of D. So it should be, what's the best way to write it? The tangent of A is the same as the tangent of D. So it should be EF over DE. That's what it should be. And that's not what it says here. So this is wrong. Okay? El tangent de ángulo A tiene que ser igual al tangent de ángulo D, que sería lado EF sobre el lado DE. Y eso no es lo que dice ahí. Así que por eso que la A está mal. Letter B says the sine of C. So here's C. The sine of C is the same as the sine of F. So the sine of F is going to be side DE opposite over hypotenuse. So side DE over side DF. And again, that's not what it says here, so that's wrong. Okay, how about the sine of A? The sine of A is the same as the sine of D. Alright, so the sine of D would have to be opposite over hypotenuse. So EF over the hypotenuse, which is DF. Again, that's not what it says here, so that's wrong. Okay, so the last one, the cosine of C is the same as the cosine of F. And the cosine of F, cosine is adjacent over hypotenuse. So it would be EF, which is the adjacent side, over the hypotenuse, which is DF. And this one is correct, because the cosine of C has to be the same as the cosine of F. Este es el único que está correcto porque el cosine de C tiene que ser igual al cosine de F. So the correct answer is letter D. All right, question 14, you got to fill in the blank. All right, you got to choose from these three answers. There's 3 blanks, and these are the 3 answers. Read that when you get a chance. Those are the answers. That's on the test, all right? Eso está en el examen. Léenlo cuando tengan un chance, antes del examen. And number 15, make sure you understand and are ready to answer a question on this proof. Okay? Estén preparados para hacer una pregunta sobre esta prueba que está aquí. Alright guys, so that concludes section 1 of the review for this exam.